1, 2, 1, 2. Okay, I guess you all hear me, right? Cool. Okay, so thanks everyone for coming here today. Hope you're all doing well, right? Okay. There's not one to go next. Okay, I'm Alexander. I work for Epignosis. I'm the chapter lead of front end, in particular in Talent LMS. Anyone ever heard of Talent LMS? Okay, there's a few. Okay, Talent LMS is an LMS. LMS stands for Learning Management System, right? We provide individuals, organizations, businesses, companies, the platform to create their own courses in order to sell them online, educate their employees, their staff, right? Talent LMS is amongst the top 5 LMSs right now in the world, right? And we want you, right? We have an open position for a senior front-end engineer. And if you are interested and you're looking for a job, you can scan the QR code. It will take you straight to the link with the job description where you can even apply, right? So if anyone is interested, you can scan the QR code and it will take you straight to the details. Our main stack is React and TypeScript. We use Zustand for global state management, Axios and React Query as API wrappers. We also use Emotion, right, for styling and style components. So if you like the stack, you can scan the QR code and hopefully you'll be one of us. So this presentation is divided in 2 parts. The first part, I'll talk about React error boundaries, a brief introduction to error boundaries. And the second part, I'll talk about how we can use error boundaries with Sentry in order to report and log our error events, and also give them more information and meaning and context in order to be able to debug easier and faster our application. So, anyone ever heard of error boundaries? Cool, cool. Have you used it? That's great. So, for those who don't know, React error boundaries actually introduced in React 16. It's actually a class-based component which captures the errors from our application. Actually, it captures the errors from its child components, right? So, what's good about error boundaries? Okay, I think, okay. What's good about error boundaries? It's that it catches the render phase errors. Render phase errors usually results in a very bad user experience, something like the white screen of death. I think you all have experienced this, right? So this is very bad experience for the user because you have to be a developer in order to know what to do, like inspect and see what's the error, right? The user usually wonders what happened, right? So this is bad, and error boundaries can catch those errors and also provide us with a fallback UI, so at least the user knows that something went wrong and he can like have a message and an action, like click here to refresh the page and something like that. So yeah, this is a typical error boundary. It's class-based, right? It has a local state. It has 2 lifecycle methods, right? Whenever an error happens in its child components, getDerivedState from error runs. It changes the local state of the component. And as you all know, if you change the state, the component re-renders. And upon re-rendering, the component that cuts lifecycle method runs. So there, if you have any custom solution in your backend, like you report your errors or you log your errors, here is the best place to do it. Next, it renders based on the condition. If has error is true, it renders your fallback UI usually. Otherwise, it renders its children. So there are two ways to implement error boundaries. One is on a global level, right, on the top level, where you can wrap your entire application inside an error boundary. And the second one is on a feature level or lower level, where you can just wrap your individual components inside an error boundary, right? So I would say that there's a third one, like a combination of both. So there are some pros and cons. On a global level, it's really easy to implement. You just wrap your entire application in an error boundary, right? And you have a fallback UI. The users have somehow some better experience. On the con side, the fallback might be too generic because you wrap your entire application, so you don't really know which application, which component actually crashed. So you have a generic UI like, oops, something went wrong. Click here to refresh your page or something like that. So, and it also, you still have a non-responsive website, a non-responsive app, because if an error happens, the fallback UI renders, and you have to, again, refresh the page. On a feature level, it's a better experience, right, for the user. You show them, again, a UI, an alternative UI, but it's more context-specific. So, for example, if you have a dashboard with widgets, with some widgets, and you have a user analytics widget, you can show him, you can render a very context-specific UI, like, oops, we were unable to retrieve the user list, or something like that. One of the benefits of the feature level implementation is that your application does not entirely crash. Only the component that is broken is being replaced with a fallback UI. So on a con side, I wouldn't consider that a con, but too many error boundaries might complicate your app, so don't overuse them. So this is how you apply on a global level. You just wrap your application on an error boundary. And this is on a feature level. As you can see, we have a dashboard here, 3 widgets. Each widget has its own error boundary and its own specific, context-specific fallback UI, like the sales chart. It has its own fallback UI, like sales chart failed to load, right? So if any of those components is broken, it does not crash the entire application. It just crashes that particular component, and it replaces with the fallback UI. Okay, now let's see some examples. Okay. Oops. Let's go. So I have a dashboard here. I have 6 widgets, right? I can cross the widget I want by just clicking on the appropriate button. So I will demonstrate first what happens if a widget crashes and it does not have any error boundaries, right? So I will cross the user information widget, the first one. Boom. That would be the white screen of death. So you just have to go inspect, go to console, and see what happens. Fail to load user profile data. Okay, but for the users, that does not mean anything. He just sees a white blank screen. So now what I'm going to do, I'm going to apply a global level error boundary and see what happens. So I will cross the same widget again, Okay, now we have something at least. That's a little bit better. Now we show the user something kind of useful, right? Application error, something unexpected happened in the application, some error details, like what was the component that crashed, the error methods. Well, I would suggest you not to show too many details about the error to the simple users, right? So, and you can just reload the page. If you're lucky, it will recover. Now, let's see what happens if I also add a feature level error boundary for this particular widget that we just crashed. So I will crash again the first widget. Okay, that's much better. The application does not crash, right? It's responsive. You can go back if you want. You can click on the other widgets, right? And you have a nice, let's say nice, fallback UI for whenever that happens. So I can crash the other ones here. Can crash my entire dashboard, and the website, it's still responsive, let's say. The widgets might not be, but you have a responsive website. So that's all about error boundaries right now. Let's dive now into the second part, where I will talk a little bit about Sentry and how we can use error boundaries with Sentry in order to report those errors to Sentry, and also give them more meaning, like additional information about the state of our application at the time the crash occurred. So I guess you all know Sentry, right? Anyone ever use, do you use Sentry? Anyone use Sentry? Cool. Cool. So Sentry, it's actually an open source platform that captures the our application errors, right? And it gives us a centralized way to look at them in real time. It gives us a nice dashboard, right? Where we can filter the errors. We can see which ones are escalating, when an error first occurred, and stuff like that. It gives us plenty of options. But most of all, it gives us its own error boundary. It's an error boundary on steroids, let's say. What it does, it's a typical error boundary, right? But it also reports back our error events to Sentry. And it also, you can add your extra context, right, to those error events. So, but what is context, right? Context, it's just an extra information that you can attach to those error events. So it's easier for you to understand the state of your application at the time it's crashed, right? It helps answer what's happening when the error occurred. So there are a few types of context Sentry gives us. It gives us the user. It gives us a method, set user, where we can set some information about the user, the time the crash occurred, like it's his ID, email, the role. I wouldn't encourage though to send to Sentry, personal information. It depends. So you can have tags. You can attach tags to errors, right? You can attach context. It's more structured, like an object, right? And it has another method that is the set extras, where you can attach single pair values, like payload size, retry count, and stuff like that. So this is the anatomy of Sentry's error boundary. So as I said, it's a typical error boundary. It gives us the fallback prop, but it also gives us the before capture prop. which is important. What before capture does is before the error event is sent to Sentry, it gives us, it allows us to add the context, the extra context, the extra information to this particular error event. As you can see, we have a few methods here that Sentry gives us. It gives us plenty more. It gives us breadcrumbs. It gives us the extras method. But here, in my example, as you can see, whenever an error occurs, we attach the user, right? The ID, the username, email, role. We attach some tags like which team is responsible for this particular component, right? You may have multiple teams. Each team might be responsible for its own part of the application. So it's easier than in Sentry to search by team, and you can filter your information there. So we also set an extra context, the chart configuration, like what options the user has before the error occur, right? Maybe there's an issue with some of those options. So let's see some code examples again. So here I have the exact same dashboard, but this time I have wrapped all the widgets with Sentry's error boundary. So let's go to Sentry. So we have no issues right now. Okay. The last couple of hours, I have one issue. So I will crash again the same widget. But before I do that, I want to show you the code here. As you can see, I've wrapped this particular widget with Sentry's error boundary, and I've set some extra context like the user information, ID, email, username. I've set the team, like the identity team, the widget type. I've set the widget configuration, right? That should be dynamic, right? This one is hard-coded. And on the other widgets, I've set team and widget type, just for demonstration. So let's see. Let's cross the user. Okay, I think we are here. Let's cross the user again. Okay, I will also cross the chart widget. Okay, let's see Sentry. Okay, now we see those errors, right? We see the load user profile, fail to load user profile data. That comes from the first widget. And if we go and click to that error event, you'll see that Sentry attaches its own context, right? It has some defaults. But you can see here, as you can see here, it has attached the user email, the username, right? Here in this section. But if you go down here in the tags and click on the custom, you'll see that it also has attached the team and widget type that we set, right? And also it has attached the widget configuration, right? So we can see what was the configuration at the time of the crash. Maybe some of those values might be faulty. We go back. We can see the other widget that crashed. I didn't set any user information, so it gives us just the IP address. And if I go down there, we can see the tags I've set, like the team, analytics team, the widget type, analytics chart, right? So when I can crash all the widgets and refresh, refresh again. Here they are, the quick actions widget crashed. So we can see that it has our tags, and we can go back here in the dashboard, and tags are actually searchable. If you set a tag and the user, you can search in the dashboard. So I can say like team and see all the errors that comes from a specific team, like for the product team. So the quick action widget, the product team is responsible for that. So I can see that. Or I can search by username, maybe the username of the user, like the dashboard user. So the dashboard user, well, we see the errors that occurred in that particular user. So this is the code here. As you can see, it's pretty simple. You can actually set context on a global level, like Sentry gives us the ability to, instead of attaching context in specific individual error events, you can just go like here and do Sentry set user. And you can have, whenever an error occurs, you can have that user information in its error event in Sentry. So I have some documentation in this QR code. If you scan it, it's a Notion page. I have some FAQ and some resources, some extra documentation. So about the context in Sentry, how you can set up Sentry and stuff like that. You can scan this and you can read more about error boundaries, the official documentation. It's pretty simple, right? So I think that's about it. Hopefully you've learned something useful, right? Thank you. Thank you. Questions?
Hello. So I have a question. So instead of prompting the user to reload the page after error boundary has caught the error, why don't you reload the page? And for example, retry 3 times and then display a toast that says